All right, so here we go. 10.2, number 11. All right, so here we go. It says a soccer player kicks a soccer ball of mass 0.45 kilograms. That is initially at rest. The foot of the player is in contact with the ball for 3 times 10 to the negative third seconds. 1, 2. And the force of the kick is given by this mess. So it's 6 times 10 to the 6th t minus 2 times 10 to the 9th t squared newtons for that time. So A says find the magnitudes of the impulse of the ball due to the kick. So what am I really doing there, you guys? Integrating, right? So for part A, we're looking for impulse, right? Again, you guys, what's the technical symbol for impulse? J. J. Why don't I ever use it? Because it's the same as change in momentum, right? Okay, it is also the same. J is joules, which also could be confusing. All right, so change in momentum is the integral of this force, which is our net force, we can assume, right? Is gravity going to be a significant force here? No, because this force is way bigger, right? So we want the integral of our force with respect to time between 0 and 0.003. So we're going to get, do I need to rewrite this? Can I just write what you get after you take the integral? Yes. Is that cool? So you're going to get 3 times 10 to the 6th t squared minus 1 times 10, no, shoot, oh, dang it. Yeah, we'll do 2/3 times 10 to the 9th t cubed, evaluated between 0 and 0.03. Terrible scientific notation then. Which of these do you evaluate first? I saw a couple people mix this up as I was working with Anya before after school. You do the top one minus the bottom one, right? It's final minus initial, because you're looking for change, right? Okay, so plug in 0.003, and it gives you whatever I said the answer was on the sheets. 9 Newton seconds. Equivalently, 9 kilogram meters a second would be fine. Cool? So that's part A. B, find the average force. Well, so that's where we come back to this. Change in momentum is, so we just found our change in momentum, right? We know our time, so you just divide, right? Cool? And that gives you, what, 3,000 newtons? Yep. Everybody good? C wants the maximum force on the ball from the player's foot during the period of contact. Huh. How do we find a maximum value of a function, you guys? Close. Take the derivative and set it equal to 0, right? Okay. So, can I erase my A and B? Yeah. So for C, let's find the derivative of the force with respect to time. So that's going to be 6 times 10 to the 6th minus 4 times 10 to the 9th t. Right? So that's the rate at which the force is changing. So set it equal to 0 and solve for t. So you get 6 times 10 to the 6th equals 4 times 10 to the 9th t. So divide both sides by 4 times 10 to the 9th. And then you get so there's our time at which the max occurs, right? Everybody good up to there? So now plug that back. What does the question ask? What is the maximum force? So plug that back into our f of t equation, and that'll give you the maximum force. Technically, we should probably ensure that it's a max. How do you do that? Take another derivative and make sure that at that time it's concave down, which means negative. You want your second derivative, at a maximum, your second derivative should be negative, right? Because your slope is decreasing. Okay? And it is, because if you take another derivative, you're going to get negative 4 times 10 to the 9th, which is always negative. All right, so for C, plug that back in. Are we good? Any problems? All right, part D wants to know the maximum velocity. Oh, well, it says what's the velocity immediately after it leaves contact with the player's foot? Well, any thoughts about how to do that? It's really one step. Trying to find the velocity it has right when it leaves the player's foot. $3,000 equals mass times velocity. What's the 3,000?
I have no clue. It's on my paper.
That's a force.
Oh, I mean delta T.
There you go. Yeah. So that's what I would do too. Yeah. Is that all right? We know change in momentum is mass times VF minus VI, right? We know our change in momentum because that was question A. We know the mass of the soccer ball because the problem told us. We're trying to find VF, and VI was 0. So just divide, and you get whatever that is, 18, 20, sorry, give me just a second. Cool, you guys?
Yes.
All righty.